Welcome back everyone to Data Science for Everyone. Today we're going to be looking at higher order functions. Let's get started. So higher order functions, or HFOs, in JavaScript are functions that operate on other functions. So either by taking them as an argument or returning them. This powerful feature allows more abstract modes of operations, like functions that create or modify other functions. They may also play a crucial role in writing concise and maintainable code, enhancing readability and reducing repetition. Now, uh, higher order functions are fundamental in functional programming paradigms and are used extensively in real world applications for tasks such as data manipulation, asynchronous operations, and making them an essential for any JavaScript developer. So, some of the basic concepts that we're going to be looking at with these are characterized. So, higher order functions are characterized by their ability to take other functions as arguments. Now, this makes them very powerful and flexible. So they operate only on basic data types, though, such as strings, numbers, and arrays. While first order functions are straightforward in their actions, higher order functions offer a higher level of abstraction, allowing for more complex operations. So let's get on into some actual real world examples. So I'm going to go on and create up a new file here, and we will call this index.html. And let me go on and put in here is higher order functions. And we'll create up this index file, HTML. And let's just do something very basic here, H1. Here will be higher order functions. And I'm just going to go on and put in actually, I don't want a script. Yeah, I guess we can just write it directly in today. That'll be fine. So our first example that we want here, let's do this as a data analytics example. And we're going to use the higher order function called map. Now, in a sales data scenario, we want to imagine that we have an array of sales objects, each containing details like the number of items sold and the total price. Now, the map method in JavaScript perfectly suited for this context. It transforms each element in the array based on a provided function. So, for example, if we want to extract the total sales amount from each object, map can be used to create up a new array containing only these values. So, let me go on and create up a the array that we're talking about. So, const sales data, and we want, let's just say items 10, total is 200. And then we'll do the same operation here. We'll do items 5, total 100. And we want items 7, total 150. Now, one thing that we should also talk about, okay? So map, so what does map actually do? Okay, so map, and maybe it'd be better if I actually go on and how about this? How about I actually go on and construct everything, and then we will actually talk about map itself so we can actually look at it. So const total sales here is equal to our sales data dot map. So notice it is a method onto an array. Okay. So again, we can see here this function that accepts up to 3 arguments. The map method calls the callback function uh, one time for each item in the array. So it's going to loop over each piece in that array. Now, what map does. So using map simplifies data processing and enhances code readability. Instead of manually iterating over the array and extracting the required data, map provides a clean, functional way to achieve the same results with less code and more clarity. It abstracts the iteration process and focuses on what needs to be done with each element, making the code easier to understand and maintain. So in this instance, we want to grab just the sales totals, okay? And so let's do that. Now we do sale dot total. So oh, and not this. This is we're actually doing we want to do an arrow function here. So what we're doing is we're taking, so this is very similar to like if we're doing, again, we're doing a callback. So we have the sale, which is grabbing this item here, and then we're doing this whole item, okay, dot total. And that's going to give us an item back. And then notice it's going to do it for each item inside here, each element inside. So we should, in theory, if we do a console log here of sales data, it should, in theory, give us back an array with 200, 100, and 150. Okay, so let's go and take a look at that. So let's inspect, and we should, in our console, have an array of 3. And notice, oh, it is actually giving us back everything here. So something didn't go quite as we expected it to. So let's take a look at what it could be. Oh, so actually, if we notice here, it's very simple to see here that this should be here our total sales, not our sales data. So let's go back over here. Let's refresh it. And notice now we have our array with 200, 100, 150. Okay, good. Now that is a real world example utilizing some map data. So again, think about if you're doing some sort of data analytics like that. Now let's go on and create up another example here with something like, all right, so this is using the map example. Let's go on and create up another one for maybe customer segmentation. And we will be using the filter method. So in, in customer profile scenarios, imagine we have an array with customer objects, each with an attribute such as name, age, and location. Now, the filter function in JavaScript is ideal for selecting customers based on specific criteria. For example, we might want to create a list of customers from a particular location. Okay, so we can also use the filter method to iterate over the array and apply the test function to each element, passing a new array with elements that pass the test. This method is efficient for segregating out data because it allows for direct and readable implementation of complex filtering criteria, specifically simplifying the process extracting subsets of data based on defined conditions. So let's go on and create up a customer uh, customer data set. So we have customer, oh, not customer, customers. And again, we wanted name. And so let's do Bob, age 55. We want location. And what type of location do we want? Let's actually give them just some cities. So let's say New York. We have name John, age 35, location Miami, and then we'll do name Jane, age 40, location, you know what, let's make this one New York as well. All right, so Now we have up our customer data, and let's say that we want to filter out just our New York customers. So New York customers. So we take our customers data set dot filter. Now again, we're going to be taking in another function here, and we're going to be using an arrow function just like we used above. And we will say customer and here we want to do customer dot location is equal to New York. And here, actually, let's make this a strict equivalency, okay? We want it exactly at New York. All right, we'll end that. And then now, let's take a look at our output here. So we'll do console log here, and we want our New York customers. Okay, and I will actually comment that out for our total sales so that it doesn't pop up for us. So I'll go over here, I will refresh, and notice now we get what? We actually grab the whole data from our customers. Specifically here, we get Bob and we get Jane with respect to their, well, we grabbed up their whole data set, okay, respect to their location. So if, on the other hand, maybe let's go on, let's make this just a little bit more complex. Whoops. And this will be uh, uh, Xander at 20 Miami. And then let's put in maybe another one, name uh, Zane, age 10. Actually, we don't want minors in there, so let's do 19. Location of um, well, you know what, let's just leave it blank. Maybe that person didn't have in any information and it's filtered. Well, we can change this again. So we can do const and we'll do Miami customers is equal to customers dot filter customers. And then we want here to grab what? Same thing as before, right? Whoops. Customer dot location is equivalent to Miami. Console log. And we want Miami customers. And let's use this. Let's actually split it up and see how this works. And let's go on and log this as well. Go over, just refresh, oh, and we get an error because customer is not defined. Oh, and this is customer. There we go. All right. Actually, don't need this for now. This is if we're wanting to maybe grab something in there. So let's do, yeah, let's just leave it like this for now so that we have all of our customer names. And again, we have their files, right? So we have John and Xander from Miami. And again, we could later on, we could grab in and say, oh, we want to know their age. Maybe this had some buying information from there. We can grab that as well, and we could do something else. So think about the data analytics example we had before where we actually grabbed a numerical value from it. Maybe then we can add something and do some mathematics with it. So the next example that we're going to do is looking at revenue calculation utilizing reduce. So again, I will comment that out. Scroll down a little bit and let's do revenue calculation with reduce. Now, in transaction scenarios, okay, so in this one we would have maybe a transaction array. We would have a list of financial transactions, each representing an object with an amount property. So the reduce method in JavaScript is a powerful tool that aggregates data. Using a calculation for, let's say, total revenue from these transactions, it would work by applying a function to each element in the array to reduce it to a single value, in this case, the total sum. Now, reduce is particularly efficient for this task, and it is elegantly condenses an array into a single value, making it ideal for summing numbers up or consolidating data points. So let's have our transactions, okay? And let's say we have amount 150, amount 200, and amount 50. Okay, so let's utilize the reduce. Okay, so const total revenue is equal to our transactions dot reduce. Again, here you can see this is going to pop up. It takes up to 4 arguments, and reduce method calls a callback function uh, 1 time for each element in the array. And what we're wanting to do here is we are going to do something just a little bit different. We'll take total and transaction, okay? And then we are going to do something like, oops, the arrow function, total plus, here let's do transaction dot, oh, okay, and I see that this is saying amount, so I have an issue over here. So we'll do amount, and this is amount. So they'll all be the same. And with a comma, 0. Okay, and then we can console log our total revenue. Okay, and if all goes well, when we do this, it should equal 400. All right, so let's refresh. All right, we get 400. Now, let's look a little bit at this reduce, because again, some of you are probably saying, what is, so we have reduce, we have some function, and then we have 0. What is 0 here? Okay, so if I go through and I do this again, transactions dot reduce, and we look at this, it actually has a couple ideas here. So it has something like callback function, previous amount, and then we have some number, okay? Well, it actually takes in a couple other initial values. So what that is this initial value. So if I said in here, and let's say that I put in 100 here instead, and I went over here and we refreshed it, notice now it is 500. Okay, so this second argument in here is the initial value. So we have for our, for example, our total here that we're wanting to output here. So if our initial value is 0, okay, then that's nice. Now what's nice is you could later on, you could have some external variable and you could put that in here. So let's say that it's maybe total company revenue, right? And you can add that in every time you have more transactions coming in, and you can add that to the total revenue. So it's kind of a total revenue calculator there. So let's go back and let's just talk about what are the benefits of higher order functions, okay, as we wrap up today's video. So higher order functions offer advantages in JavaScript programming. They enhance code usability and they help design, they can be useful to design a variety of tasks across a bunch of different applications. This leads to less duplication of code. So again, we're keeping things dry, right? Don't repeat yourself. So comparing tasks done with and without HFOs, consider like filtering data without HFOs, you might actually have to use a loop or conditional statements, which can be very verbose and less intuitive. Now, with an HFO like filter, though, the same task can be accomplished very concisely, declarative line of code, clearly expressing the intent of making the code more readable and maintainable. So, what are some of the best practices to actually and common mistakes that are used? Well, understanding functional concepts. So, the grasp of functional programming, uh, eh, as it will help in effective use of the HFOs. Now, keeping your functions pure. So, aim for pure functions. Now, these are functions that don't alter external state and return consistent outputs for the same inputs. So, as arguments for HFOs for predictable results. Now, we also want to avoid overcomplexity. Now, while using HFOs can actually make your code more concise, using too many nested functions can lead to less readable code. So we need to strive for a balance between utilizing HFOs and creating up and not using them. Finally, you reuse functions. Maximize the benefits of HFO by reusing functions across different HFOs. Now, what are some pitfalls and some things you need to avoid? Well, excessive nesting. Too many nested HFOs can make your code really hard to read. Ignoring performance. In some cases, HFO can be less performant than loops, and especially for large scale data sets. Okay? And again, we'll talk about that more in videos when we start utilizing larger data sets. Losing context. So, for example, the this object, right? So be cautious with the this keyword in HFOs because it can change unexpectedly. Again, not all HFOs are going to be solving the problem. Sometimes it's a simple loop or a conditional is going to be more appropriate. All right. So finally, what have we discussed today? Well, we've gone over three different examples utilizing map for data analysis, filter for data segmentation, and reduce for aggregating data. Now, it's important balance to have HFOs to avoid overcomplexity, and we need to make sure that we have efficient coding practices. So, if you guys like this video, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye bye.